Welcome to Learn with Postbomb. Today we're going to be learning about force, contact force, non-contact force, type of forces, newtons, mass, gravity, and all that, and everything that has to do with force. So this video is best if you're about to write exams. So please like and subscribe, and let's get to the video. So what is a force? Well, a force is a push or pull acting on an object. So the action of push and pulling, the action of push and pulling, that is a force. So push, pull, push, pull, push, pull, push, pull, push, pull, push, pull, push, pull. That is a force, ladies and gentlemen. So there are two types of forces, contact force and non-contact force. So contact force needs direct physical, I'm emphasizing physical contact. For example, this guy, he's in direct contact with this thing physically to be able to apply the force, and this guy is in direct contact with these two blocks physically to be able to apply the force of pulling, and this one is of pushing. And non-contact force, it doesn't need direct physical contact and act through a force field. For example, a magnet. A magnet does not need to be in direct physical contact with metals or with magnetic objects to be able to pull it. It can pull the magnetic object or magnetic coins with a magnetic force field, which is invisible. So this one, apply forces without touching or without direct physical contact. So here's an example of contact forces. Friction is an example of a contact force. Air resistance, compression, and tension, these are all examples of contact force. So friction happens when two objects rub against each other. So here are two objects. One is being pushed, one is being pulled. Being pushed, one is being pulled, one is being pushed, one is being pulled. So they're rubbing against each other, and scientifically we call it friction. Now you might be surprised about the air resistance being an example of contact force. For example, a hair dryer. A hair dryer is going to push your hair. When it blows, it's going to push your hair, which is a force. A force is being applied. So it needs to be in direct physical contact for you to be able to push your hair. If the hair dryer is, let's say, far away, you don't be able to push. The air won't be able to push your hair. So it needs to be in direct physical contact for you to be able to push. That's why it's an example of a contact force. Another example is when a paper is falling. When a paper is falling, the wind, the air is going to push it. It's going to kind of like push it, which is going to make it to slow down in the air, or a parachute, or all that. So just know that air resistance is part of contact force. Compression is also part of contact force. You pushing somebody, you are applying pressure on something or someone. That is an example of a contact force. And tension also. Tension is pulling. When you pull something, when you pull a rope, when you pull a person, anything that has to do with pull is tension. Anything that has to do with pull is compression. Anything that has to do with rubbing is friction. And air resistance is also a type of contact force. Here's an example of non-contact force or field force. Gravity, weight, magnetic force, and electric force. So gravity pulls objects towards Earth, and weight is how much force gravity is using to pull you down. Magnets attract or repel things, and electric force charge objects attract or repel. So as I speak right now, gravity means pull. Just know that. Just know that gravity, it's all about pulling. It's all about pulling. That's gravity. Okay? Okay, that's gravity. Now, weight is how much force gravity is used to pull you down. So you thought that weight is kilograms, is like 50 kilograms. Like when I ask you, what is your weight? You're gonna say 60 kilograms, 50 kilograms, and which is wrong. Weight is actually how much gravity force is being pulled. The amount of force that's pulling you down, the amount of gravity force that's pulling you down, it's 60 newtons. That's weight. The amount of gravitational force that's pulling you down, the amount of gravitational force that's weight. Magnetic force, I mean, you all know that magnets, they attract magnetic objects without touching them, like from a distance, and they can also push other magnets without touching, using a magnetic force. Now electric force is like magnetic force, but it doesn't need magnetic object. Electric force does need charged objects. It works exactly like magnets, but does not need magnetic objects. So you can actually test electric force right now at your home. So this is what you're gonna do. So in order for you to test electric force, you need a ruler and a cloth or a book, like in between your book. So you're gonna apply friction on the ruler, rubbing the cloth, the dry cloth, and the ruler up and forth, applying friction, or in between a book, push, pull, which you're going to be applying friction. When you apply friction, the ruler is going to gain electrons. and electrons is negatively charged. So the ruler is going to be negatively charged. When the ruler is negatively charged, that's when you tear a piece of papers, put it down, and those pieces of papers are going to be positively charged. So you apply friction on the ruler between a book or between a cloth, making it negatively charged, and you're going to put it next to the piece of papers, and you're going to see the piece of papers are going to be pulled like a magnet. They're going to be pulled onto the ruler as if it's a magnet. So, and this is going to happen because of the ruler is negatively charged and the paper is going to be positively charged. So that's electric force. Electric force happens with charge, magnetic with magnets. So now let me tell you the difference between weight and mass. Mass is the amount of matter in an object, like amount of stuff in an object. The amount of stuff in me is 60 kg. So that means that's my mass. That's not my weight. That's my mass. And weight is the force of gravity acting on that mass. Weight is like how much of the gravitational pull is pulling you down. It's pulling down your weight, your mass. That's weight. So mass is measured in kilograms and weight in newtons. Since weight is a force, it's a non-contact force, then it will be measured in newtons. All forces are measured in newtons. Now, mass does not change with location. 60 kilograms in Germany, there'll be 60 kilograms in Spain. You'll be 60 kilograms next to the equator. You'll be 60 kilograms on the moon, on Mars. Mass does not change based on location. But with weight, it changes because weight is the amount of gravity is being pulled down. The amount of gravity is pulling you. That's weight. So Earth has different gravity. The moon has different gravity. Mars has different gravity. That's why weight, it changes with location. The instrument used to measure weight is a balance scale, a scale that you're used to, a balance scale. And to measure weight is a spring scale. I'm going to show you the images of that right now. The formula of weight is mass times gravity. An example of mass is a person has 50 kg. An example of weight is they weigh 49 newtons. So how do you know a person with 50 kg, his weight? Well, you take his weight, which is 50 kg, times the gravity. The gravity of Earth is 9.8 meters per second squared. That's the gravity of Earth. The gravity of Mars is different to Earth, but the gravity of Earth is 9.8 meters per second squared. In order for me to know the weight of the person, I take his mass, which is 50 kg, times the gravity. This is going to give me his weight, which is 490 newtons. So a person who has 50 kg, his weight is 490 newtons. So you right now, go and weigh yourself on a scale and then find out how much mass you have. After finding out how much mass you have, use this formula. Mass times gravity. The gravity of the Earth is 9.8 meters per second squared. Then you'll get your weight. Comment down below your weight. I'm curious to know your guys' weight. Everything here stands for yeah. The M stands for this. The S stands for this. The S squared stands for this. So here's an example of a balance scale. And here's an example of a spring scale. As you can see, a spring scale is measured in newtons. And you put your object here to show how much gravity is pulling down the object. That's why you kind of like hang the object. And here's the example of a spring scale in real life. So 9.8 meters per second squared, it means that for every second something is falling, its speed increased by 9.8 meters per second. If you want to know, what does it mean? Okay, now in summary, mass is how much stuff you are, and weight is how hard as gravitational force pull on your stuff. And here's the formula of weight. Bam, you can weigh 500 kg. I don't know what a bear weight. I'm just giving an example. And this buckle can be like 2 grams. Okay, let's say 20 grams. So since this bear is 500 kg, the amount of weight is going to be higher because there'll be more gravitational pull. There'll be more gravitational pull. Like it's being pulled. There'll be more gravitational pull. So for example, there'll be, let's say, about 1000 newtons. That'll be the weight of the bear. Like the gravitational pull that's pulling the bear down for it not to float will be 1000. And for this will be, let's say 10 newtons. So here's the mass, 500 kg, and the weight is measured in newtons is 1000. To show you that like the amount of gravity that's pulling it down is 1000 newtons, and here is 10. So that's just a quick example. So how does eating work then? So when you eat, you're adding matter to your body. You're adding mass to your body. And since weight equals to mass times gravity, that means the more mass you have, the more weight. As you said, the bear had more mass, that means it has more weight. There'll be more gravitational pull on it. Yeah, that's how it works. So here are Newton's 3 laws of motion. First law, an object stays still or keeps moving unless the force changes. For example, your phone will stay still until you move it. The first law is quite simple. Second law, force equals to mass times acceleration. A heavy box needs more force to push than a lighter one. The third law is every action has an equal and opposite reaction. You jump off a boat, the boat moves backwards. So for example, when you punch a punching bag, the punching bag will move backward to you. So that's the third law. That's Newton's 3 law of motion. Yeah. The king of physics, you can say like a crown. So here's the formulas that you must know. The formula of force is equal to mass times acceleration. Now, and mass, the formula for mass is mass equals to force divided by acceleration. The formula for acceleration equals to force divided by mass. So it's kind of like this. So for you to find force, you have to multiply m times a. For you to find a, you have to divide F times m. For you to find m, you have to divide F by a. So here are the formulas. And here's the formula in this kind of triangular formula. If you know this triangle, if you don't know it, it's fine. You can memorize the formula like this. F equals to m times a. But this one is the best one to know. F is on top, and then m and a is in the bottom. So you multiply here to get F, you divide. Let's look at examples. When finding force, they're going to give you a statement saying you push a box with a mass of 8 kg and it accelerates at 2 meters per second squared. So for me to find the force, the amount of force, as you know, all forces are measured in newtons. For me to calculate the force, I'm going to do mass, which is 8 kg, times acceleration, which is 2 meters per second squared. It's going to be 8 times 12, which is 16. Knowing that the amount of force here was 16 squared. Now, me finding the mass, a force of 30 N. So now I have the force. Now, a force of 30 N is applied and cause an object to accelerate at 5 meters. So for me to find the mass, I'm going to divide the force, which is also on top, which is also going to be the denominator, the force divided by the acceleration. And then the answer will be 6 kg. And for me to find the acceleration, I'll divide the force. A 20 N force is used to push a 4 kg object. So for me to find the acceleration, meter per second squared, I'm going to divide the force, which is, okay, I don't know what happened here, but I'm going to show you. I'm going to divide the force, which is 20, by 4, which is going to be 5. That means the amount of acceleration is going to be 5 per meter squared. So this basically is a formula to find force, mass, and acceleration. This is the formula. This is a formula. So these are the questions they might ask you in the test. So let's go through them together. Define a force. A force is a pull and pull action happening or acting on an object. Name 2 contact force: compression force and tension force. Give examples of non-contact force. While example of non-contact force is magnetic force and electric force. Yeah. What is the difference between mass and weight? Well, mass is the amount of matter an object has. Weight is how hard its gravitational force is pulling the mass. Basically, use the formula to calculate force. As I said, we went through that example. Describe Newton's law with examples. We went through that example. So what type of force is acting on a falling apple? Let me give you guys a chance to answer that. If you say gravity, if you say non-contact force, well, you're right. Non-contact force is the one that's acting on a falling apple. So in summary, force is push or pull. The formula for force is mass times acceleration. Force is measured in newtons. All forces are measured in newtons. So weight, gravitational force, compulsion force, all forces are measured in newtons. Mass is measured in kilograms. Gravity on Earth is 9.8 meters per second squared. Weight is equal to mass times gravity. The formula of weight is a formula for force. Mass is not the same as weight. They are different. Mass is how much stuff is in you, and weight is how hard it pulls on you. Contact force needs charge, like friction and tension, and non-contact force doesn't need charge. So please, guys, share it, comment, like, and subscribe, and make the algorithm love me. I hope you understand this lesson about forces. I think we covered a chapter. I think we covered a topic, a whole topic in under 30 minutes, in under 20 minutes. A whole lesson explained everything. So I hope you guys like and subscribe, and I hope you guys pass your exam. Thank you very much.